very anxious to hear your talk from Sky Nelson Isaacs, Meaningful History Selection and Equation for Synchronicity.
Thank you so much. And I want to ask if there's a volunteer who'd be willing to come up and do my slides for me. Thanks, great. And I want to take a second to acknowledge my angst in the couple hours of wanting things to flow, and I actually study flow from the perspective of synchronicity. I'm very interested in Mihai Csikszentmihalyi's work, because I think that when we live in a synchronistic, paying attention to synchronicity in our lives, we experience more of a sense of flow. And so I try and live that way, and maybe not so much in the past 2 hours. Thank you very much. So I'm going to talk about a research project I've been doing for the past year or so that's been funded. I'm grateful to the Federico and Elvia Facchini Foundation and the Foundational Questions Institute. And I'm at the point where I've got an equation for synchronicity. So I'm going to share with you what that is. There's a lot more work to do, but I had a deadline of being ready for today, so thank you. First of all, I'm going to say what my basic views are. I'm not going to question these today. These are just where I'm coming from. First of all, in quantum mechanics, I think that only properties exist. This is based on research from people like Merman that I really appreciate. So an electron is an electron. When we measure it, we get certain results. These are the properties, like the charge or the mass or the spin. But what's really there? Well, we can't say anything about what's really there. All we know is the properties. So the cosmos is a bunch of properties that we're interacting with, and when we interact with them, we get a property back, or a value for that property. And that's all we can say. So next, I'm going to say very tentatively that properties equal qualia. Because in quantum mechanics, you write a property down in a ket, in a symbolic representation. And actually, I've seen professional physicists, instead of putting like spin up or spin down, put happy face or sad face. It's symbolic of something. There's something there about this, the nature of that in some sense may be appropriate to describe fundamentally the experience of qualia. I equate qualia and experience, the qualitative experience of whatever it is that's happening right now in the moment. So I'm going to take those as equal, and I'm going to say that experiences or qualia are fundamental. So actually, to some very extent that we're not going to talk about today, physics comes out of experience. I'm not going to argue with that today, but I'm going to come from that perspective. We start from that we're all having experiences, and out of that, certain circumstances, certain physical circumstances show up in order to bring us particular outcomes. And finally, my perspective on quantum mechanics is that it's relational. The collapse of the wave function is relative to an observer, and that it's macroscopic. So everything, and I think I've shown this, but I have more work to do. But it applies to all objects, and we have to understand why that is and how that goes against our common sense. That's me. So, also, this is way outside my expertise, but I'm going to say that experiences are the core thing that are going on, qualia, the core thing. From that, we have reactions, which we call emotions, which are in our body that we can't control. Feelings are more of our stories around our emotions, the broad range of the feelings that we have. Like, I'm about to go on stage, I have a certain emotion of fear, but I might think that's a horrible thing, that would be my feeling, or I might think that's an exciting thing, that would be a different feeling at a different situation. We don't have control over the emotions, but we do have some semblance of control over the feelings and the thoughts. And these can go both ways, and right in here is where I think we can place synchronicity. So if I have a grumpy attitude when I wake up in the morning, my wife's likely to be grumpy back, right? That's causal. But I'm also suggesting that if I have a grumpy attitude, I'm actually going to be more likely to experience situations which make my life worse and grumpier, whether it's a clogged drain or whatever. And that's where I would suggest synchronicity comes in. Certainly, I have a huge amount of work to do to demonstrate that experimentally, and I'm going to do a little bit of that work today, but I'd just like you to go with me on that for today. So I'm going to define synchronicity. I'm going to set up a thought experiment about being on the subway in New York City. And then I'm going to describe a logic experiment that would be able to model that. And the method I'm going to use is to create a tree in time. In quantum mechanics, in the many worlds view, you might be familiar, the wave function of existence is branching. And what we know is that there's this evolution that's both unitary, it evolves, and it has branches at every interaction between every particle and every object. There's a branching based on how many different ways it can turn out. So that creates a tree in time, and we're going to try and model that using two-state vector formalism and consistent histories. Thank you. So Jung's definition was the events that are meaningfully related but not causally related. So let me give you a brief example. I'm running to a play in New York City on Broadway, and I have to catch the subway. And the subway is coming into the station as I'm walking into the ticket, where to buy my ticket. And so I know I'm not going to catch it because I still have to buy my ticket and get down the turnstile. So the question is, do I run or do I not run? And what Carl Jung and I would say is that if I run, there's really no chance of me catching it anyway, so there's no purpose. But if I run and something happens in the turnstile or in the platform to delay the train by 30 seconds, and then it gives me enough time to get down there because I'm running, that would be a meaningful coincidence. It would be a surprise event that would have some meaning, some correlation to what I was wanting. And what I'm going to suggest is it's not what I'm wanting, it's an anticipation of a qualia that I'm seeking to have, or an anticipation of qualia. So I'm actually not running because I want to, what I'm really trying to do is get to the experience of having salty popcorn on my tongue, and bright visuals and sound from the play, and a friend with me that I'm having a nice experience with. These are the qualia that I'm seeking to have. And so by running, I'm actually, that's what I'm experiencing. And it's those qualia that I think are driving, the anticipation of those qualia that I think are driving this process of what I call meaningful history selection. So my definition of synchronicity is the same as his, but more practical. An event which becomes more likely because of its causal relationship with a future post-selected situation. So the future post-selected situation is that I'm seeking to have these qualia experience of the play. I'm anticipating the experience of salty popcorn on my tongue. That's the future post-selected situation. The person, like if there's a bicyclist on the platform that gets stuck in the train the train doors and blocks the doors, that's totally unrelated to me, but it is related to the future of me getting to the theater on time, because it actually leads causally to me getting to the play on time. Because if that bike gets stuck, the train will delay, and I will get to the platform on time and get on and be up and get to the play. So do you follow how this event of the bike getting stuck is not related to me running? There's no correspondence between those two things. But if I do run and that happens, then I do get to the play on time. So there's this causal relationship between the middle event and the future. Okay. So catching the subway, there's a tree that I'll show you here. Keep going, thanks. So if I rush, I'm going to end up on this branch. You can just go through these gradually. And there's an equal chance, let's just say, of these two branches, S and S bar. And there's a 50-50 chance based on those amplitudes. And that's fine, you can leave it. It just jumped. But what happens is, go back one slide if you will. Oh no, go forward one slide. So this weight happens here as a result of the post-selection that we're going to do. And it weights down this branch. And that is going to create this event, which is going to be 55% now. So the end result is I'm going to try and get a slightly higher biased likelihood of this intermediate event. And in this case, it's a subway train waiting for me long enough. So this is the synchronistic event. And before it was 50-50, now it's slightly biased towards this event. And we're going to see if we can create that in the lab. So keep going. Thank you. So using some of the work in the weak vector formalism, the two-state vector formalism and weak measurement and Aharonov's group, we can start with 3 electrons, 1, 2, 3. And the first electron is in spin up. So we know its state. The second electron is in some possibility of both states, and the third electron as well. So K and L are both indices that are summed over. They can take all possible values of 0 or 1. And this is a sum of actually 4 possible outcomes. A up, B up, C up, A up, B up, C down, A up, B down, C up, etc. And there's an amplitude here for each one of them. So keep going. And we're going to apply an operator, which is a version of a Bell operator, which entangles these. And what's going to happen is we're going to entangle them. 3 separate electrons in space at one moment are going to be entangled to become, we're going to throw out these 2, and this one's going to have 1 electron at 3 different times that are entangled. So we've got 3 different electrons, A, B, and C, and these have indices K and L. And then the next thing that happens is we apply the operator, and we have now this electron has the state BK at a second moment, and has the state CL at a third moment. So we've now created a tree of possible states, because K and L both vary from 0 to 1. So this goes from A up to B up to C up, or A up to B up to C down, just as these did. But now these, we can get rid of those. They're ancillas. And this is one electron at 3 different times. So this is how we create and then we have the same equation, but this is actually representing 1 electron at 3 different times, not 3 electrons at the same time. So we have a tree that looks like this. That expression looks like you either go left, and then left, and then left, and you get up, 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 or you can get up, up, down, or up, down, up, etc. There's 4 different branches you can travel on, and each of them have certain transition probabilities. B up, C up, up would be the transition probability for this branch, and B up for getting to here, and C up, down, down for going there. This would be down, sorry. And so we can work with this, and the next thing we do is apply this post-selection. Now this is a controversial step, because we do it in the lab. There's good experimental data that this is interesting, but we don't quite know what it represents. Because what you're doing is throwing out the data that doesn't match the conditions that you want at the end, and looking at, of the data that matches this condition, how does it behave? So we can go into why I think that's useful and applicable in a real-life situation, because we are observers and we're actually only experiencing one outcome. We're not looking at the statistics of all the possible outcomes. But that's a separate story that's really worth debating at another time. For now, we can do this in the lab, and we can look at the results. So we're basically post-selecting a certain profile of outcomes. We're making this number higher and this number lower, so we're biasing towards the down state, which means this branch and this branch are going to have a bias in this acausal way, this post-selective way. Causality is coming up from below, and these things are describing the causality, the B and the C's. The alphas are describing this acausal, I don't want to say backwards in time. I'm saying we're selecting certain outcomes in the future and seeing how they affect the intermediate steps. So this represents the subway scenario. We have 3 different states, up, 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 down, up, up, down, up, as we said. And the amplitudes are pretty straightforward. Alpha up, B up, C up, up is this one, with this one, with this one. So that's this branch right here. So now we have the amplitude of each of these branches post-selected in a specific way. And that's the key point. We have both, you can go one more forward, we have both causal amplitudes going this way and this acausal amplitude based on our post-selection. So this is how we're going to get an effect that's not just trivial. We can calculate the weight of this whole branch. We're not just looking at the weight of this outcome. We're looking at what's the weight of this entire section, which is basically the weight of this branching point. If I was to go left, what would the weight of that be? And the weight comes from adding or multiplying out the branch amplitudes and adding them together. This is sort of the weight of the apple that goes on this branch. This is the weight of the apple that goes here. We add them and we square them because to get a probability, we square it. We do the next one and the next one. We do that for both branches, and we can find the actual probability by normalizing this branch over the 2 branches. And if we do that with some numbers, that's fine. So, yeah, that's perfect. Now, here's where the numbers become important. So we have 2 equal possibilities here, right? This is 0.7 on each branch. So the way we set this up is an equal likelihood of going either way. We could set it up differently, but that's really easy to work with. Now, if I go left into the spin-up state, or this is in what I was calling the subway train gets delayed state, in the macroscopic version, which we can use as a metaphor at least, if not real. If I make the subway, I'm much more likely to get to the play on time, and this was the not late branch. So that's why there's a high amplitude here, 0.6 versus 0.37. If I make the subway, I'm most likely to get to the play on time, and not getting to the play on time is probably not going to happen. If I miss the subway, then I'm probably going to not make it to the play on time, which is why this is heavy. And making it to the play on time gets a smaller amplitude. But I'm post-selecting with this high value here. 0.9 and 0.44 are the post-selection, and 0.9 is higher than 0.44. So I'm selecting for branches 2 and 4, and that combination is going to give us some weights. So what the weights it gives us are 0.17 on this branch, 0.11 on this branch, and keep going. And then the normalized weight is 55%. So by doing this, without this process, we would have had a 50% chance of going either way. In other words, in the metaphor of having the train get delayed or a train not get delayed. But by this process, which I claim is related to the qualia that we anticipate having in the macroscopic example, we have amplified or elevated the probability of having the up spin or having the train get delayed by 5%. So we can just go through these maybe 1 second at a time. We went from equal chances. This is the electron that chooses a spin state. I mean, it's at this point, this is its spin. We're post-selecting with these numbers. This has a large apple because of these numbers, and now it's got a 55% chance to go this way and a 45% chance to go that way. Different from the 50-50 chance it had before. And so what I'm proposing is that this kind of influence allows us to understand how a synchronistic situation could emerge, not certainly, but with higher probability than just chance. It's got an elevated likelihood of happening. This intermediate event has an elevated likelihood of happening based on the qualia that we are anticipating having in the future based on our actions down here. So we could potentially tie this into an experiment where we do this whole experiment with